Welcome to 3.3's video. So here we're going to be expanding on our 3.2 where we were proving triangles congruence, but now we're going to be providing reasons as well for each justification. So, and you'll notice there's a cute little fox here, and this is actually part of an extra credit project if you want to do this. So let's go into it right now. So we can look at some of this stuff here and I can say, okay, well, AD bisects angle A. Well, what does a bisector do? Well, a bisector means it cuts it in half. So this part equals this part. I'm going to mark the picture like that. Then it says AD is perpendicular to BC. Well, that means that's a right angle. That's a right angle. And then AD is the same as AD, so I can mark that. So I can prove that these two triangles are similar, or not, congruent by angle, side, angle. And my justifications would be for angle A, I could say that angle BAD equals angle CAD because of the definition of a bisector. For this side, AD, well, AD is the same as AD, that's reflexive property, so I would just say reflexive. Oh, gotta list the reason. I would say AD is equal to AD because of reflexive. And lastly, I could say angle ADB is congruent to angle ADC because that's the definite, they said it was perpendicular, then that makes right angles. So I could say all right angles are congruent. So last video, you were doing the triangle is the same, and you were giving the reasons, just angle, angle, side, 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 side. Now we're going to have to list why each angle, side, or angle, or whatever, is the same. So here we have another one. So suppose that angle DBC, so that's this, equals angle ECB, that's this, and angle DCB, this is getting a little confusing because now I got two lines here. One trick to do is to draw separate triangles. So I want to take apart this triangle, these two triangles. So I'm going to say this is A, B, and C. And no, that shouldn't be that. No. Okay, so I got them separated. We're not going to be using angle A. So now I have these two separated, and when I mark the text here, I can say that BDC, which is this one, is equal to ECB, which is this one. And then I can say that DCB, which is this one, is the same as EBC, which is this one. And then I look here, and what else? Oh, well, BC is the same on both, so I can mark that. So I could say triangle DBC is congruent to triangle ECB. And C is the same as B, so they're listed second. C here is the same as B here, so they're listed third. The reason I would say would be that the two angles are the same because of the given. So now that they're separated, I could say angle B equals angle. Nah, I still won't do that. No, it would be very confusing to do that. I'm going to say angle BC D is same as, that's given, so there's told to us. I would rewrite those, part of my homework, and then I would say that BC equals BC because of reflexive. So if you have overlapping triangles, figure out what triangles are trying to be congruent, redraw them separate, so that way I don't have a line here and two lines here, and that would have been two lines there, and it's harder to visualize it. Okay, another one. So suppose AB equals DF, and angle A equals angle D, and BE equals FC. Do I have congruent triangles here? Well, if I redraw it really briefly, like this, I've got A is the same as D, AB is the same as FD, DF, but the bottom side is BC and EF. And are those two the same? Well, they can be, because EF is the same. Let's put some numbers in here for fun. If this is 10 and this is 4, we know this is 4. Well, then 10 plus 4 is the same as this 10 plus 4. So I can say BC equals EF because of segment addition. A precursor step to that would probably be to list that EC equals EC because of reflexive. And I'd also need to state in that step that BE equals FG. So knowing this is equal and that this is reflexive, I can then add the segments together. The other ones, this would just be given and given. And I could then say the triangle ABC is congruent to triangle DFE. On Delta Math, you're going to get some triangles, shapes that have shared surfaces. So here CA is the same. So that would be a reflexive property. And I have an angle, and a side. So I could say that these are the same because of angle, angle, side. On this one, this is a great example of one where I would want to separate the drawing. And I would have two triangles, sort of like one laid on its side. This is angle B. And then I have angle C and D. And then this is E and A. And I know angle A and C are the same, so I can mark that. I know that BD, which is on this triangle, is the same as BE. And then I only have two things, but I need three. Oh, good thing I drew them separate, because I could say angle B equals angle B here for angle, angle, side. This one, this would be reflexive as well, but you also might be getting one where there's vertical angles. So I would say that AEB is the same as angle CED because they are vertical angles, meaning this angle is the exact same as that. This one would be the same as this one, and they're vertical. So, three-part question here. Suppose AB, big one, equals AC. What additional information would you need to conclude that triangle ABE, so that's this triangle, is congruent to ACD? So this is a great one where I would want to redraw my picture. That would, no, hold on. Okay, so I got separated. I messed up on the colors. So we want to know what additional information you need to conclude that these two triangles are congruent by side, angle, side. So for this one, I need to look, and I'm glad I separated these because now I can see that angle A is the same in both. So if I want to do angle, side, angle, that would be an included side. So I would need to know that angle C is the same as angle B. What would I need to know to prove that these two triangles are the same by side, side, side? Well, I only have one side is the same, so I would need to prove that side AE is the same as AD, and that BE is the same as CD. And then what additional information would I need to do for side, angle, side? So that's going to be included angle. So I would need to know that side AE, which would be this side, would be the same as AD, that side. Here's a great diagram that has all 5 reasons of why you will be able to prove that two triangles are congruent. And when you're proving these, you'll need to have, for side, 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 3 sides that are proven, and usually will be given or reflexive or something like that. I need to have the supporting evidence for 3 things. For side, angle, side, I need to have the supporting evidence for 2 sides and the included angle. So as you're looking through this, if I already have 2 angles, well, I'm probably not going to use one of these ones. So I just have to figure out how can I get a side and where is the side. If I have 2 sides already given, I'm probably not going to use these 2 because I would need to not use one of these sides and get 2 angles. You're not going to have you be doing that much hard work. So to our lesson essential question, we've got, and this is totally weird. Okay, fix it real quick. Can I prove triangle congruence while providing reasons? So we just went over that. Check out the extra credit project, which is you being able to make one of these using congruent triangles. So a little sneak peek. This triangle here is the same as this triangle here. And then this black triangle here is the same as this black triangle here. This little white triangle is the same as this little white triangle. And lastly, this bigger orange triangle is the same as this orange triangle. So that's an extra credit project in addition to the regular project, which is a bridge project. To get ready for your lesson essential check-in, there's a Delta Math and a Mathia. So good luck.